Hi guys, good morning. Today we are going to discuss about the topic combustion in diesel engine or combustion ignition engine. Okay, let we move to the slides. Please, if you have any doubt, please don't hesitate to ask me in the description link. Okay, fine. Okay, guys. Before move to our topic, we need to discuss about the concepts engine. What do you mean by an engine? Nowadays, we are without the vehicles, we are moved to the smaller places. We are forgot to walk. Hopefully, what I am saying was correct. Not only was of myself also. I am wherever I want to move from my home. I look for a bike or I look for a car. Okay, so both the two wheelers and four wheelers, the main functional part in that vehicle is an engine. Okay, engine is also called as a powerhouse. Okay, how we can took our human body like heart. Okay, the role of the engine is the similar to the heart. This engine is the heart of the vehicles where it controls all the process, because once the power house, the engine works perfectly, only we will receive the power for the vehicle for its self moving. Okay, so guys, where the engine, while we discuss about the engine, obviously we touch the fuels. Okay, the engines are classified using two fuels now. Predominantly we people are using petrol and diesel. Okay, so other thing, in this petrol we are using CNG. Okay, and then other our LPG is also possible fuels, but in this case of our diesel engine, we are only using diesel as the fuel. There is no other setup is also not possible. And nowadays the technology developed where people they are using hybrid vehicles. In this hybrid vehicles we are having that electrical compartment separately. So we don't want to look over there. Okay, we only concentrate on these cases. So engines are powerhouse of the vehicles, where the function of the engines is classified into the based on the fuels what we are using nowadays. Where petrol, in the same engine we are using CNG and LPG. Then same the other case we are seeing the diesel engine where we are using diesel as a fuel. So based on these fields, where based on the process started, it can classified, or it is also called as an SA engine. That means spark ignition engine. This is called as CA engine. That is called as compression ignition engine. Okay, so the spark ignition engine, where this is similar to petrol engine, both are same. Where the petrol engines, where we need some additional spark to ignite. Those things you people may aware of. We need additional spark to ignite. For this diesel engine, we don't want that additional spark due to the compression pressure. Okay, it will ignite itself. Both the fuels are self-ignited in the nature. First of all, what do you mean by self-ignition? Self-ignition in the sense, guys, where there is any transformation in temperature. If I am simply hold that petrol in my hand, what happen? It will get vaporized. Similarly, I will hold the water in my hand. Okay, it also vaporizes, but the temperature difference is more. It can vaporize in very minimum temperature petrol, where water requires some higher temperatures above 100 degree to vaporize. So all the liquids are self-ignited in the nature. But this self-ignition temperature for this petrol is very low while compared to the diesel. So this self-ignition temperature is very less for our petrol engine. So it requires some amount of external source to ignite itself. That's why we are using spark inside the cylinder. But in the case of diesel engine, the self-ignition temperature of this diesel is very high. It can self-ignited with minimum of temperature. And just to simply have that both the petrol and diesel in my hand and keep in the atmosphere, what happens in a smaller piece of time, around 1 minute or 2 minutes, the diesel vaporized fastly, but the petrol slowly it will get vaporized. So this is the difference between both the fuels. And some other thing we are discussing in the same lineup, Okay, while we are speaking about that self-ignition temperature, obviously the flash point and fire point are plays very a key role in these fields. So the flash point is nothing but the flash point refers the ignition temperature, how fast is get ignited. That is called a flash point. Once the flash is get, then you move to the fire. So both the flash point and fire point is higher for our diesel engine. Okay, this simply changes vice versa. Everything is lower for our petrol engine. Okay, once we are seeing separately while we took the flash point, then fire point. Flash point of our petrol engine is very less when compared to our diesel engine. The fire point of our diesel engine is very less when compared to our petrol engine. Vice versa, it will be changed. But don't get confused about these terms: flash point, fire point, self-ignition temperature. Simply keep in your mind where diesel can evaporate fastly when compared to petrol in the our atmospheric temperature. Our atmospheric temperature around 30 degree or 34 degree Celsius nowadays, where in this atmospheric temperature, where diesel where evaporate fastly while compared to our petrol. Okay, just to keep these things in your mind. So today's video, guys, we are going to discuss about the concept of how the ignition happens. What all the stages of the ignition is there in the diesel engine. So before we are entering into the topic, okay, always I am preferred to discuss with the basics of our concepts of video what we discussed today. Same. The diesel engine was invented by Rudolf Diesel in the year 1892. So, guys, in earlier days, where the concept of engine development is there, okay, Carl Benz developed its own engine, okay, as well as the production unit was developed by Toyota groups, okay, as well as these automotive units there in the world, they are giving small development for the engine development. Finally, okay, Benz who developed a final structure for the engine. People see the older structures. Okay, I didn't have the image. I will show in the next video where we are you people are seeing that one. So those images of older vehicles is that design. Engine should be have like this. Wheels are should be there, and this is the compartment. All the information is first designed by Carl Benz. So that's why he is called our father of our vehicle. So Rudolf is one of a German scientist who initially he discovered the diesel engine. Okay, so the main goal for this Rudolf, why he moves to the diesel engine is to get high efficiency. Normally, guys, when comparing to our petrol engine, the horsepower, okay, the torque of this diesel engine is higher while compared to our petrol engine. That's why the diesel engine always having a separate maintenance. Noise also higher while compared to petrol engine because the power produced by this diesel engine is highly more while compared to our petrol engine. So this is the basic concept of our diesel engine. Okay, why it will have, why we need to concentrate the diesel engine. So next basics is internal combustion engine. Guys, based on the combustion, okay, where that engine is classified into two categories based on the combustion. One is uh, internal combustion engine, the another one is external combustion engine. Consider this is a combustion chamber, nothing but a cylinder, where the combustion takes place inside. Where the combustion takes place inside. Okay, this is called as IC engine. All the engines are internal combustion engine. Where this is the cylinder, where the combustion takes place in the outside. This is called as external combustion engine. So by the property enhancement or for achieving more power, okay, we are discovering a new unit or new products for what the new products are competitive to each other. If I am using a laptops with iCore processor 3 third generation means why people are preferred fifth generation speed. The same case to achieving more performance, guys, where they are discovered so many of concepts in these engine setups like weight, component designs like connecting guard, a piston, a cylinder, a crankshaft, okay, then propeller shaft, whatever may be the components what we use in our automobiles, everything is derived for some application purposes. So finally they will conclude that this is the size, this is the shape. From the size and shape we are achieving some power. So everything they will discuss. So likewise, guys, where the performance what we achieve through our internal combustion engine is well higher, while move to the external combustion engine. Whenever that combustion process takes inside the cylinder, then only we have that maintain the controlled environment. Another best example is where I am having the candle with me. Okay, I'm keeping the handle inside a glass with an openings. Okay, how the flame is flamed, you people can imagine it flamed with a controlled action. There is no disturbances there for that flame. Same, I am just to simply keep that candle in the outside without any cover, the flame will shows its movement. So this movement is a disturbance, guys. Actually, this movement is a disturbance where it can affect that out. Okay, we are expecting 100 percentage output. It's not at all possible from the thermodynamics second law for the system. Where not at all we are getting 100 percentage output. So from that one, we are expecting some 98 or 97 percentage. Where when this 98 and 97 percentage of that efficiency is also disturbed when we are did this combustion outside here. That is the this is the basic reason, and this is the basic formula why people they are preferred this combustion. Okay, sorry, internal combustion. Guys, we already know where the petrol engines are classified based on the strokes. Okay, four strokes is that because earlier days we are having two strokes due to the pollution standards and everything. Nowadays the trend is changed, as well as our government also recommended only for the four strokes. Once we are going with four strokes, the only benefit is we are getting very good combustion. The cycle is completely ended. Okay, till the fuel is converted into the smoke. But while moving with the two strokes, what happens? The cycle doesn't completed where more amount of pollutants is released in the form of gas to the atmosphere. So the four strokes are suction, compression, power, and exhaust. Okay, and remaining that valve opening and closing. In the case of our diesel engine, we doesn't have that valves in the front. We just denoted by means of port because there is no need for opening and closing of valves here. Okay, only the in the inlet port where that fuel comes, diesel come inside. Okay, once the diesel come inside, where the air plus, there is no concept of after the concept of air plus fuel mixture is happens. Once the air fuel mixture is happens, the fuel is coming inside to the combustion chamber. Okay, in the second stroke is compression. The fuel is compressed. Due to the compression temperature, the fuel get ignite. Then it we will get the power and it will exhaust. So this is a normal thing happens in the our diesel engine. Similarly, in the petrol engine, instead of in the second stroke, I mean in the compression stroke, after the compression is completed, where in the third stroke of ignition, we just simply put a power or we have give that ignition through our spark plug. Through that spark, the fuel petrol get ignited, then vehicle turns to move. So this is a simple concept of our petrol engine, diesel engine, how the power is produced. So by these are our basic introduction for our um, engine blocks normally what we people have. So now guys, our topic is stages of combustion ignition engine. Guys, whether we are going with the stages, these four stages is there. The first stage is ignition delay period. Then second stage is pre-mixed burning. Then third stage is mixed controlled combustion. Then fourth stage is after burning or tail feature. Guys, I hope that the image is visible to you. Okay, where these stages, where it happens. Now you people are having a mind. Whether when these stages are happens, these stages are happens in the ignition. You people are have the first stroke. Okay, first, second, third, fourth. So first stroke is suction. Okay, the second stroke is compression. Okay, the fourth stroke is ignition. And fifth stroke is exhaust. So in this area, in this third stroke, we are having these stages. Okay, this third stage we are having this one. Okay, where this case we can link this fourth also because the fuel is completely converted into gas in the third and the fourth stage. Okay, the fuel get ignited. On the fourth stage, the fuel is completely converted into yes. Okay, that's why they are having the graph like this. Okay, we have the inverted bell type curve, but the bell type curve where it represents the process where the starting of the ignition, then after the ignition stage how it will. This is the two things where this graph explains to us. Guys, again I will repeat, if you have any doubt related to this video in the stages, because in each and every stage the main important parameter is temperature and pressure, because this temperature and pressure plays a main role in the state of ignition. Okay, so please listen to me. The another that portion of the piston you people may know. Okay, in each and every stages, the portion of our piston may be there in the different places. In the top, either it will be the top portion of the cylinder, otherwise in the bottom portion of the cylinder. In this case, in the third case, where in the time of our ignition takes place, where the portion of our piston is in the top portion of the cylinder. That means please listen to the diagram. Okay, I will draw the image how it should be. Consider this is a cylinder. Okay, this is the portion of the piston. Yeah, actually, this is BDC and this is GDC. For our case, our piston is here on. Okay, from this, the main important factor which rules out the combustion is pressure and temperature. Okay, please listen to me, guys. We are seeing the stages slowly. The first stage, ignition delay period. So the ignition delay period is the period where the fuel doesn't ignite. Please listen to me. However, we are study the ignition part of the fuel, where this is the ignition, this is before ignition, and this is after ignition. So this period, this area is our first step, where ignition delay period. Where in this ignition delay period, the happenings are only the fuel come inside the combustion chamber. Okay, so how the ignition delay period will act, or how the ignition delay period will react? The ignition delay period will react by means of two concepts or two properties of the diesel, physical as well as chemical. The chemical properties and physical properties of our diesel will completely responsible for the ignition delay period. Actually, this is not a flaw. It is normal thing happens inside the cylinder. Normally, the diesel would show some lateness before the ignition, because that compression would be happened there. Okay, so this is a normal happening. This is not a flaw, guys. Don't get confused. So the physical delay is due to the fuel is not atomized properly, and it will be vaporized due to the self ignition temperature. We already discussed what do you mean by self ignition temperature in the earlier of this video. Then chemical delay is, this delay is due to the reaction of chemicals. That means inflammation takes place. Okay, inflammation like that, the factors like temperature, which may responsible for this case for chemical delay. So the both the delays where is a normal process. It's not a flaw. So both the physical delays and chemical delays is responsible for our ignition delay period. We can see this in the diagram where we can see that ignition delay, where always the ignition delay is here below the start of the ignition is here. This is around, the temperature range is around 20 degree, with the pressure of that fuel, compressed fuel is around 38 bar of pressure. Okay, now the second stage. The second stage is pre-mixed burning. So the pre-mixed burning is the stage where the self-ignited temperature of the fuel get rise. It seems to be what the fuel is ready to burn. Okay, the fuel is ready to burn, and also the fuel is ready to releasing its heat. Okay, guys, is ready to releasing is heat. That heat is our power. Okay, so this is called as pre-mixed burning. The fuel is ready to release maximum amount of heat in this stage where yeah, where the maximum amount of heat is released, then obviously the power is produced. Then mixed controlled combustion. The controlled combustion stage is nothing but where the variation in the temperature and the pressure due to the inlet of the fuel. Normally, the fuels are coming inside the combustion chamber in the form of droplets. Okay, in the form of droplets, they will come inside by with the help of the air plus fuel mixture. Okay, with the help of the air plus fuel mixture, where we are having this one. Nowadays, the air plus fuel mixture happens due to the fuel injectors. You people may know aware of. In earlier days, people they are preferred carburetors. Nowadays, for the air plus fuel mixture, we are using that fuel injector, where which have which can spray that air plus fuel mixture inside the car, cylinder with more amount of pressure. Those things we can discuss it in some other video, but just to keep these points in our mind. So the fuel always come inside our combustion chamber in the form of spraying, and just simply spray the air plus fuel mixture inside the combustion chamber. In the initial stages of our process where the engine process combustion takes place. Initially, the air plus fuel mixture ratio is more for the ignition. Then once the process is started, okay, slowly the intake of that fuel is reduced. The air is more. So that's why we are whenever we are driving the vehicle, we always give a constant acceleration for better mileage. So those things you people may aware of. Okay. Then the next stage is mixed control stage. In this mixed control stage, where we are getting maximum numbers or maximum amount of efficiency. So what I understand, the same concept is there in the mixed control combustion stage. In the mixed control combustion stage, where we are having the intake of the diesel is very less, with more amount of air inside the combustion chamber for getting maximum fuel economy. Okay, but the efficiency is same. The efficiency rate is same, but economy of that fuel is there. Okay, so that is the third stage, mixed combustion stage. Then final stage is where the combustion process is completed, where the fuel is completely burned out. Now we are having the gaseous particles in our hand, where that gaseous particle is sent out to the exhaust to the atmosphere. So in this case, where that degree of opening is around 70 to 80 percentage of crank, it will be there. It is traveled over that cylinder where TDC to PDC to expose this kind of process. The only important thing is we need to look out from this graph. Okay, I'm already said that that time where that degree of movement shown by that crank piston inside that cylinder, as well as the rotation of the crank in various angle, okay, to measure the where it locates. That means piston where it locates in various pressures and temperatures. Okay, this is this from this graph I will explain the same. Okay, where the starting of the ignition, where the position of the crank is there in the TDC, those things you people may aware of. But in between that fraction of seconds, where we need to cross over all this. Okay, we need to class for all these four happenings in between their fraction of second. Starting of the ignition, on the ignition, starting of the injection, where the starting of the injection, where the air plus fuel comes enter into the pot. Once the air plus fuel mixture come into that pot, where what happens, we are experiencing some ignition delay. This ignition delay due to the some physical and chemical properties of the fuel. Then next stage, once the delayed ignition period is completed, the next stage is where the fuel is ready for the combustion. That means the fuel is ready for the burning. From that burning, we are having some heat. Okay. In this second stage, we are facing two concepts. One is pre-mixed burning, and one is mixed control burning. Pre-mixed burning, we are having the air plus fuel mixture with more amount of fuel with less amount of air. The mixed control combustion, where we are having more amount of air with minimum amount of fuel. Then after burning, where what happened, the combustion process is completed. So then it is exhaust. Exhaust in the sense where it will releasing that exhaust gas to the atmosphere. This is the four stages of our combustion happens inside our combustion ignition engine. Okay, guys. Then another important thing I want to discuss with you. Okay, so in the first stage, okay, the ignition delayed stage, ignition delay is there. Then second stage is uncontrolled combustion is there. Then third stage is controlled combustion is there. Then finally exhaust. Same thing here they mentioned in the different name. The stages of combustion they are mentioned in the different name, but the both having same meanings. Because initially we won't control the combustion. Okay, the reason why means we need to ignite that fuel. So once we are need to ignite the fuel, what we need, we require more amount of fuel to ignite with minimum amount of air. The ones we want to control, that means we are focusing on the economy of the output. Once we are focusing on the economy of the output, we are look for the less amount of fuel with more amount of air. The same thing they are giving. Don't get confused. Okay, this is the stages here. So this is the point where pre-compression takes place. So pre-combustion in the sense ignition delay. Then second, the combustion is ready to take off. So there we are having uncontrolled combustion to C to D. Then after that uncontrolled combustion can travel, we need to settle them into a single point that is called controlled combustion. Then finally it will release. So this is the simple concept. I am said already where the pressure and the temperature and location of that crank in that means the piston in various position because the position of the piston is fully controlled by the rotation of the crank. Okay, so the same concept they will discuss here. Then another important thing I want to discuss with you, knocking. What do you mean by knocking? Few people may hear of knocking is nothing but stucking of that piston inside. I will draw the diagram with you now. Okay, consider this is the cylinder. Okay, this is the piston where we know the revolution and everything. The piston will it moves up and down where the crank rotates like this. Once the crank rotates like this, where it move, the piston moves between top dead center and bottom dead center. Okay, the piston is locked in between the cylinder. Otherwise, where the top portion of the piston as well as the top portion of the cylinder is completely damaged. How it get damaged means excessive wear. Okay, then due to not proper combustion takes place, not the engine performed well, not the sensors are not performed well, then not the where we won't get some correct point of air plus fuel mixture inside the combustion. These are some responsibility of knocking. Once knocking is there, what happens? The piston will rotate 2 or 3 point up and down. Then immediately what happened? The engine will stuck over. Once the knocking is happened, uh, obviously we need to change the piston and cylinder because it's completely it will damage the top portions of our piston and cylinder. So it's a flaw, it's a defect. Actually, knocking is a defect or it's knocking is an accident. It happens for the engine due to the wear of our cylinder and piston. Okay, so once the knocking, some of the major causes like timing, what I have discussed earlier, then as well as the ignition, okay, and all the activities happens inside the cylinder between the four stones. Everything is responsible for the knocking. Okay, some of the knocking parameters is there. Just simply read out these knocking parameters. Okay, that's all, guys. This is the one additional thing I want to discuss with you. Knocking. So knocking nowadays knocking is not at all possible because we people are if we maintain our vehicle clearly, okay, by means of providing all the services or check regularly keep checking our vehicles where we won't experience knocking. If there is any flaw in the temperature systems like where we are having that radiator which is connected to the engine to reduce the temperature, if there is any problem with the temperature controller unit, I mean the radiator, the flow of water inside the system, so that also responsible for that rise in fall of the engine temperature. is another key factor which is responsible for the knocking in both CA and SA engines. Okay, both the CA and SA engines, but the knocking where we can preferably seen in CA engines than the petrol engines. Okay, guys, that's all about this video. I hope you people are understood what I am discussing today about the various stages of our CA engine. Okay, if you have any doubt in this means where you can frequently contact me through the link where it is available through this video's description. Okay, thank you guys. I hope you people are have some inputs about this video. Thank you. Thank you.